Hello my dear achievers, welcome to your very own channel BYJU'S 9th and 10th. I am your teacher Saurabh and today we are here to discuss conservation of momentum. Now I understand when I say this particular topic, a lot of CBSE students are thinking, sir, why should we study this? It's not there. You're right. ICSE students are thinking, thank you sir for bringing this because you promised you'll take concept for CBSE also, but where were they? Today it's here, right? Okay. Now, for people who are thinking, sir, why should we study this particular topic? So I'll tell you two reasons. First, this is something which is not difficult. It's not something you are going way out of you are supposed to read or study. You are just doing, I would say, small changes to what you have already learned and understanding this topic. Second, this is a very important topic. See, today, whatever you are learning now, it's fine. I don't want you to be confined or restricted to the syllabus you are supposed to study. That's fine, right? Some concepts are here, some concepts are here in this board, in this board, in this board. But what is important is your contemporaries, right? If you are in class 9th, for example, everybody in class 9th, whatever board they are learning something. And whatever each of these students are learning, they all will be using it in class 11th. And somehow in future when they'll give exams, the competitive exams, they'll use all these learnings. So today if you learn less, tomorrow you'll learn more. If your basics are clear today for everything, what everyone is reading, you'll be easy. It'll be easy for you, right, tomorrow? So that's why I'm telling you, be equal to everyone. Don't be less. ऐसा नहीं होना चाहिए कि कल बच्चा है, अरे तुमको ये क्वेश्चन पता है, ये कंजर्वेशन में होगा, तुम बोलोगे यार पता ही नहीं, मैंने पढ़ा ही नहीं, ये होता है कुछ. I don't want that with you. Understand this. It's not difficult. I'll explain you and you will understand everything. That's my promise to you. But I want you to be alert. I want you to listen very carefully. And I want you to not think, sir, live to nahi hai, it's premiere, so shall I just sit? Don't just sit and watch. Be active in the chat. Why? If you are just sitting, you know what will happen? I'll tell you. Sir, nice sir, I'm understanding. Oh, you lose things in between. If you are active, if you are answering everything, and I'm saying to everyone who is watching this session, if you are answering everything, be active in the chat. Don't just sit idle. बैठना नहीं है चुपचाप, सो जाओगे. Be active, listen very carefully, have your pen notebook with you. I'll give you the PDF also, don't worry, right? Now, the video which you saw, and whatever I just told you, I want you to understand this, that there are few exams which take care of your all over learning and testing. This exam is one of them, the Aakash National Talent Hunt exam. The thing which I tell you every time, make sure you register for it. Why sir? 100% scholarship you will get. It's an all India level exam, means you get an all India level rank. There are very few exams which do this, at least for this particular stage, right? Make sure you give this. You will get all India rank. You will get cash rewards. You'll get 4 ANTHE mock tests the moment you register. Sir, how to register? Link is there in the description. See, make sure you have a habit of checking out the descriptions of the video. They are very important, right? So, 4 ANTHE mock tests you will get. You can give them anytime. Okay? Link वहाँ पर है. Register from there. Online exam is 5 to 13th of November. Offline is 6 to 13th of November 2022. 7 से लेके 12 तक. 7th class to 12th class. Everybody can give. And everybody will have a different paper. I'm not saying 7 to 12, everybody same paper, right? Don't worry about this, right? Now, if you are not motivated enough to give this, let me tell you one more thing. People who do well, they will get an all expenses paid trip to NASA. Rocket to सबको पसंद है ना? That's why, right? All expenses paid trip to NASA. That's important, okay? All right, so all this we are doing to bring you here. And not just for boards. Trisha was an all-rounder. We all know this. The interview is there on the channel, by the way, right? This year or this academic batch, we got 2,600 plus students who got 90 above. You can be one of them. Just be regular, listen everything carefully, and you'll be good. Don't worry about this, right? And how will you do this? How will you do this? How will you get the mehnat ka result, the hashtag mehnat ka result? If you get good result, obviously you have done mehnat or hard work. That's what we call, right? खाना में मजा आता है जब मेहनत करिए उस खाने के लिए, right? Hashtag मेहनत का result. Result तब मजा आता है जब मेहनत करिए उसके लिए. So that's why. Are you up for the mehnat ka result? Yes. Make sure you subscribe to our channel because then only you will be an all-round learning. Because I have seen people who are irregular, no, they struggle. In some sessions we do, they struggle. Sir, ये समझ नहीं आया. But we already done sessions for that. So make sure you are regular, you are watching all the sessions and do what I'm saying. You'll be sorted. Don't worry about this, right? Okay. Now, people, as you can see, there is something here. Can you tell me the name? Come on. Tell me the name in the chat. Come on, come on. It's okay, I'm not able to read it, but at least your classmates can, no, whoever is there. Tell me, what is this? Newton's cradle. It's a brilliant thing, I would say, right? It's a pretty brilliant thing. If you just do it like this, normally people use it as a showpiece. People who don't know about this, they use it as a showpiece at their houses. But you know what? It's a great scientific, I would say, demonstration of conservation of momentum. Sir, how does it work? How does it work? Alright, I'll tell you. I'll give you first of all the problem statement. See, when I take one ball and release it, on that side, one ball is thrown away, right? If you release one ball goes back, comes back, this goes back, right? This is happening, fine, okay. Watch, if I release two, on that side, two balls go away, right? Okay, fine. But you know what? The most amazing thing happens when you release three. Because intuitively, I'm feeling, sir, I'm releasing three. Here are two. I don't know what will happen. Right? Can you guess what will happen? Come on, tell me in the chat. Very quickly, tell me. What do you think will happen? Let's see. Can you notice it? When I release three, on that side also, three ball only go, right? Correct. Why is it happening? Why is this happening? Come on, try to answer, because I want you to try to answer, because the more and more that we progress into this session, by the time we end this session, you will tell me the answer yourself. And you know what? Tomorrow, you'll just move to your friends. Tomorrow kya hoga pata hai? Some friend of yours, they'll bring you this. Hey, pata kya hai ye? Do you know how it works? You will tell them, I know how it works. Are you ready to understand Newton's cradle? Let's understand this. There is a name, right? The scientist's name in this, Newton's cradle. Let's start with the great Isaac Newton. The great Isaac Newton and the law which he gave. So he gave three laws, first, second, third. Yes. But if we are about to start conservation of momentum, I would want you to focus on the third law. Because third law, pretty simple. And in a way, conserve of momentum can be derived from third law and very easily. Bahut easy hai. You just have to listen carefully. Okay? What does Newton's third law state? Sir, it's very easy. For every action, there is equal and opposite reaction. Bilkul sahi, you are right. For every action, there is an equal and opposite reaction. By the way, I'm hoping you are answering in the chat, right? For every action, there is an equal and opposite reaction. Yes, sir. And do you remember I gave you one more definition? And I told you the definition which I gave you, if you remember that, this particular thing, or a lot of things about third law where people make mistakes, they will just be sorted automatically. The definition I gave you is, if body A applies force on body B applies same force on body A in the opposite direction. Hai na? ठीक है? Alright. Let's see. Examples are pretty easy. Right? Whenever shell is fired from the tank, it moves backwards. Yes. Right? It moves backwards, correct? Right? That's true. Hai na? Okay. It moves backward. But why does it move backward? Why does it move? Tank pushes the shell and the shell pushes the tank. Simple third law, right? I'm pushing the shell pushes the tank, shell goes there and tank moves backwards. Fine. Alright. ठीक है. And I'll ask you one more question. Have you seen a drone? Forget about this thing. Forget about this particular thing. I'll ask you another question than this. Yeah, I know. I was planning some other question, but you know what? I changed it. I don't want you to get confused. That's why I changed this question. The question to you is, why do you think the drone is flying? When it is at rest, sir. It is just sitting nicely. But when it is flying, why do you think it flies? I don't know if you watched. There was a masterclass on drones, right? Vipul Sir came in that. And in that masterclass, how many of you watched it? Come on. Think. Hai na? If you did not watch it, please be aware that, almost every Sunday, we bring out a masterclass. Make sure you log into byju'sexcel.com. Okay? So, in that masterclass, it was shown when a drone is flying, a dry ice was brought near it. The smoke from dry ice, the drone was pulling the air and pushing the air down. Oh, so drone is pushing the air down. Now, Newton's third law says, if drone is pushing the air down, air is pushing the drone up. That is how the drone is flying. Simple, hai na? Okay, fine. That's how it flies. All right. Multiple examples. You pushing your friend, right? We have done this, the first one in the class, by the way, right? Second one also we have done the class. If you are swimming, you push the water back, water pushes you forward, and that's how the third law works. Simple, hai na? in all these things, let's just make it very explicit what we are discussing. We are discussing that these two forces are always equal in magnitude but opposite in direction. Third law statement. And second thing is action, reaction act on different bodies. When I give you this statement, and I'm telling you this is very serious, when a lot of students remember it like this, sir, for every action there is equal and opposite reaction. It is not wrong. It is right only. But when I say if body A applies force F on body B applies force F on body A in the opposite direction, then the second statement, one thing becomes really clear. There are two objects. These two forces are acting on different objects, right? True. Nice. So if you understood this, let's talk about this particular animation. See what's happening here. Focus. Sir, there is a silver or white ball, correct? There is a white ball, right? It is traveling towards the blue ball. Okay. Blue ball looks small, right? So what is happening? Blue ball is going, white ball is coming. I'm making a bigger hand for this. White ball is coming, right? And it strikes the blue ball and white ball slows down. Blue balls gain some speed. Okay, nice. Okay. What do we call this? What do we call this phenomena? What is happening here? दो बॉल टकरा रही हैं, क्या बोलते हैं? Collision हुआ, right? That is what we hear in news, no? है ना? Two cars collided. Like if you read newspapers, whenever these kind of accidents happen, they give this headline: collision, right? It's a very normal and casual term which we use in daily life. So collision is something which we all know as in Hindi टकराना, टकराव, correct? Okay, ठीक है? Now I want you to do something, and that is very important, and I will not tell you here. Let's talk about action-reaction pair in collision. Sir, what do you mean? ठीक है, Newton's third law याद है? Do you remember Newton's third law? Fine. Now focus. First of all, there are two balls, black and white. Fine. I have given them black and white so that it's easy to pronounce. Silverish and blue. And दिक्कत होती है. Let's keep it simple only. White and black. ठीक है, black छोटा है, white बड़ा है. Black is small and white is big. Fine. Now, I want you to forget about the white ball. For a moment, forget about white ball. Just notice the black ball. क्या हो रहा है? Notice. Only black ball. Sir, there was a black ball which was going like this. Suddenly, its velocity increases. What is velocity? Velocity is the speed with direction, है ना? It is the magnitude of speed with direction. कितना तेज चल रहा है और किस डायरेक्शन में चल रहा है? That is what velocity is. No, rate of change of displacement. Fine, easy. तो क्या हुआ यहाँ पे? If you just focus on the black ball was going like this. Suddenly something happened and its velocity increased. By first law said a body will keep on moving with same velocity unless there is a net external force. If velocity of black ball increased suddenly, I don't know what happened because I don't know there is a white ball. No, I don't know what happened. Black ball's velocity increased suddenly. Matlab there was a net force on it. Yes. Who applied? Now, I can see a white ball. Who applied the force on the black ball? White ball, है ना? तो B पे कौन लगाया force? Or I would say black body पे कौन लगाया force? White ball लगाया. Who applied force on the black body? White ball did. Fine. Now focus on the white ball again. अब black को भूल जाओ. Forget black. Focus only on white, है ना? Guys, listen very carefully. I know you might feel this is getting boring slightly in between, but if you just hold on for a few minutes, no, इसके बाद आपको ऐसा मजा आएगा ना, सर ये तो सोचा ही नहीं था हमने. I'm telling you, focus, listen carefully, and concentrate. Forget about the black ball. Focus on the white ball. What is happening? Sir, there was a white ball which was going, and suddenly something happened. Its velocity decreased. Okay, I don't know what happened, right? White ball was moving with some velocity. Suddenly its velocity decreased. Okay, fine. If velocity decreased, matlab there was a force, right? If there was no force, its velocity would not change. But there is a change. It decreased. There was some force, correct? Okay. Who applied? White ball applied. है ना? White ball applied. So can we say this one particular thing? The moment when they were applying force on each other, white applied force on black. Black applied force on white. Newton's third law, right? Right? Correct? Yes. Newton's third law. So, FAB. See, this is the ball A. This is the ball B. Its mass is A. Its mass is B. Fine. Now, let's assume something. Before these both of them got collided, टकराने से पहले they both were moving with some velocity, right? Let's see the initial velocities of, or let's say, initial values, right? Initial values for ball A. For ball A, initially the velocity was, let's say, VA. Oh, sorry, not VA. I would say U, because we are more habitual with U, no? Let's say it was UA. Fine. And for ball B, it was UB. Okay? UA was the initial velocity of ball A. Kaun sa ball? White ball. UB was the initial velocity of ball B. Kaun sa ball? Black ball. Fine. Now, after collision, at least we all agree to it, कि after they got collided, both of their velocity changed, है ना? Let's say it was, for A it was VA, for B it was VB, ठीक है? UA and UB are the initial velocities of ball A and ball B before they got collided. VA and VB are the final velocities of ball A and ball B after they got collided, है ना? Collision एक incident हुआ, उसके बाद velocities change हो गई, that's why. Fine, all right. Till here it's okay. Nice. Now, can we think of how much force was applied? Now, if you think, see, second law says F equals ma. Yes, sir. Second law says, second law. What does second law says? It says F equals mass into acceleration. बहुत बढ़िया. This is something which we know, right? F equals mass into acceleration. All right. Now let's talk about, I would say, force applied by A on B. है ना? First, who is B? Black is B. Fine. So we said on B, some force was applied. कौन लगाया? A लगाया. White ball लगाया. Right. So that's why FAB. Understand the lingo. It is the force on B by A. ठीक है? Force on B by A. अच्छा. If I am studying ball B, how much force was applied on ball B? If I want to just calculate this, I would say mass of ball B multiplied by acceleration of ball B. Alright, sir, what is acceleration? It is the rate of change of velocity. Matlab, what is acceleration? Acceleration is final velocity minus initial velocity upon time taken. True. Now let's see. Mass of ball B, this is the mass. This value is acceleration, right? Final velocity of ball B minus initial velocity of ball B upon the time taken. So got it. Force applied on ball B by ball A is how much? Mass of ball B multiplied by acceleration of ball B. ठीक है? Alright. Similarly, can we say force applied on ball A by ball B? Right? This is what? This is the force on A by ball B. Right? Force on A by B. It will be how much? Sir, ball A पे we have to find the force. मतलब mass of ball A multiplied by acceleration of ball A. ठीक है? Mass of ball A is ma. बढ़िया. Acceleration of ball A will be how much? Final velocity of ball A minus initial velocity of ball A upon time taken. Alright, sir, we got this. Understand very carefully, people. I know you are not fond of mathematics, at least in physics. It's important. Today, if you understand this, class 11 mein you will be the hero in the class. I'm telling you. Focus. Okay? You got FBA also. Badhiya. Chalo. है ना? If you know force applied on B by A, if you know force applied on A by B, tell me something. You know about third law, right? Third law is FAB equals minus of FBA. Now, listen very carefully because this is where a lot of students get confused. Sir, what are we saying? Bhai, dekho. Third law said force applied on A by B is equal to force applied on B by A. है ना? Correct? Yes, sir. I understand this. ठीक है. Force applied on A by B is in which direction? Bhai, force is a vector quantity. It will have some direction. Okay, it will have direction in this direction, right? A पे B ने फोर्स लगाया किस डायरेक्शन में? इस डायरेक्शन में. ऑलराइट. B पे A ने फोर्स लगाया किस डायरेक्शन में? इस डायरेक्शन में, राइट? सो फोर्स ऑन A by B is in this direction. Force on B by A is in this direction. Newton's third law says that both of these forces are equal in magnitude. Third law ये बोलता है ना, दोनों ने एक दूसरे पे जो फोर्स लगाया that is equal in magnitude. Yes sir, that is equal in magnitude. Okay. But they are opposite in direction, right? They are opposite in direction. Matlab, if I say force on B by A, if I do negative of this, है ना? If I do negative of this, will it become this? Now they both are equal. Correct? Understand it like this. देखो, coordinate axis में this is positive direction, this is negative direction. If let's say right side में there was 2 Newton force, है ना? Left side में there was minus 2 Newton force, है ना? Now if you want to equate them, can you write, sir, this wala force is equal to this wala force negative. So minus of minus 2 Newton will become how much? 2 Newton. And then you can equate them. right? So that's why this negative sign came because of the direction thing. I hope this is clear because this is very important and lot of you will get confused, sir माइनस क्यों लगाया? माइनस समझ नहीं आया. माइनस लगाया ताकि हम इस डायरेक्शन की फोर्स को इस डायरेक्शन में कर सकें एंड देन ओनली यू कैन इक्वेट देम ना. यही तो बोल रहा है थर्ड लॉ, है ना? ऑल राइट, so this is what third law is saying. So FAB equals minus of FBA. Let's do little mathematics, little calculations. Sir, how? FAB कितना है? It is, I'll just open this, है ना? So MB, right? MB into VB minus MB into UB upon T, right? Is equal to minus of MA into VA. Now क्या होगा? देखो, if I write minus, so first of all if you open it will become minus of MA into VA, then minus minus will become plus MA into UA, right? Plus of MA into UA upon T. भाई T तो same है, I'll cancel T, right? Okay, I'm getting something. Now notice, what if I take all the U's in one side and all the V's in one side, है ना? सारे initial velocity को एक साइड ले जाते हैं, सारे final को एक साइड ले जाते हैं. So I can take, I would say, U this wala here and this wala here, है ना? So this will become how much? MA VA plus MB VB will become equal to how much? MA UA plus MB UB. What do you notice? What do you notice? Actually, what happened here? What happened here? By the way, this thing was on this side before and this thing was on this side. अब क्या interchange कर दिया ना, एक ही बात है. It's not, this should not be a problem. So MAUA plus MBUB. Sir, MAUA, there is something called as momentum ना, है ना? There is something called as momentum. What is momentum? Sir, mass into velocity of the body. बहुत सही. Right? So MA into UA, can we say it is the mass of body A multiplied by initial velocity of body A? So this is the initial momentum of body A, right? This is the initial momentum of, or initial P I would say. For momentum we use P, right? Momentum को M थोड़ी बोलते हैं, P बोलते हैं ना. Initial P of A. This is what? Initial P of B. MBUB, mass of B multiplied by initial velocity of B. It is the initial momentum of body B. बढ़िया. MAVA, final momentum, final P of body B. MBVB, final momentum of body B. Sorry, this one is A, right? What are we saying? Sir, क्या बोलना चाह रहे हैं हम? हम बोलना चाह रहे हैं initial momentum of body A plus initial momentum of body B. You add them. It is what? Total initial momentum of both the bodies before collision. Notice my wordings. Listen to me carefully. Left side में क्या है? Momentum of body A initially, momentum of body B initially. If you combine them, it is what? Momentum of body A plus momentum of body B before collision initially. Right side में क्या है? Momentum of body B finally, momentum of body A finally. If you combine them, what is the right side? Right side is the total momentum of both the bodies after collision, है ना? Finally क्या है? So you know how I will write this, right? How I will write this? I'm just rubbing this by the way, right? Because you know this. Total momentum before collision is equal to total momentum after collision. भाई दो ही तो बॉल है. There are only two balls. Total momentum before collision is equal to total momentum after collision. And you know what? You have derived the law of conservation of momentum. Yes, this is what law of conservation of momentum is. Mass A, mass B. The law says in an isolated system where there is no external force, the total momentum remains conserved. Sir, what is this isolated system? I told you, it's all about perspective. Newton's third law, when you were applying, you were looking at only one body. है ना? You were looking at only one body. Sir, how? You were saying body A applied force on body B. Body B applied force on body A. And these forces were equal and opposite in direction. है ना? This is what you were saying. अच्छा, body A ने body B को मारा. Body B ने body A को मारा. लेकिन if you understand both of them together, है ना, if you take both of them into the picture, तो क्या हो रहा है? Inside this box, whatever happens, that is not your concern. Why? Externally तो कोई force नहीं लगा. There is no force externally. भाई body A ने body B को मारा, body B ने body A को मारा, दोनों ने एक दूसरे को मारा, ठीक है, घर की बात है, अंदर में जो हो रहा है सुलझा लेंगे ना भाई. आपको क्या मतलब है? Did you do something? Did you put an external force in anyone? नहीं सर, मैं तो कुछ नहीं किया. जो हुआ घर के अंदर हो गया ना. A ने B को मार दिया, B ने A को मार दिया, काम खत्म. है ना? This is what happened. A applied force on body B, B applied force on body A. Whatever happened inside the house, I don't care. It's an internal forces. So what you are doing while applying law of conservation of momentum is you are taking system as combined of both the bodies. In third law, what you are doing, you are looking at body B. अच्छा बॉडी बी को ए ने मारा, ए ने मारा, ए ने मारा. अच्छा, so मतलब बॉडी बी ने बॉडी ए को मारा. Body B struck body A struck body B. Equal and opposite forces. But now what you are doing is you are saying, for me both of them are equal. For you both of them are like a family. है ना? तो family के अंदर जो हो रहा है I don't care. Until and unless there is net external force. भाई understand this also. I'm telling you one more way of understanding. ठीक है? If you are confused, listen to me carefully. भाई body A was moving some initial velocity. Body B was also moving with some initial velocity. Can I say together? If you consider both of them together, is there any external force on them? No sir. Why? Because both are moving with some same velocity ना. दोनों का जो velocity है वो constant है ना. इसका है UA, इसका है UB. It is constant, है ना? Means there is no net external force on any of them. As a system, if I tell you, after collision, whatever happened inside हुई, है ना? Whatever happened, घर के अंदर हुआ, जो भी हुआ, है ना? But क्या हुआ उसके बाद? इनकी velocity change हो गई. But did you do something? बाहर से कुछ किया क्या आपने? नहीं सर, मैंने तो कुछ नहीं किया बाहर से. There was no net external force. So whatever happened, these were internal forces. So that is why this law is applicable when there is an isolated system. So in third law, you are focusing on one body, है ना? You are focusing on one body and one body separately. But here you are focusing on both of them together. This is your system. When there is no external force, the total momentum remains conserved. बहुत ध्यान से सुनना, बहुत जरूरी चीज है ये. And this is what is happening in Newton's cradle, right? This is what is happening in Newton's cradle. If I release this, sir, sir, you are applying force. This is not the thing. I'm applying force. I'm holding it. But you know what? From where I'm counting it? Before collision. When I release it, momentum of one ball is getting transferred through the next. Tuck. Oh, है ना? This is what is happening. So when I release one ball, momentum transfer of one ball happens, and on the other side, that one ball only goes because momentum transfer is happening of one ball. If I release two balls, momentum transfer of two balls is happening. And that's why on that side, two balls need to go, right? Momentum transfer, same thing, correct? Because momentum should be conserved. Now listen to me. If I take three balls, I'm releasing three balls. Momentum transfer of three balls is supposed to happen because momentum should be conserved, right? And conserved, sir, why? Because I will release it. After that, there is no force, na? Focus. When I release them, what is happening? Three balls go, and on that side, momentum should be transferred of three balls. But sir, there are only two balls. That is why one ball from here is taken that side and it goes like this. Getting it? And that's how the Newton's cradle works. Getting it? It's not rocket science. It's not difficult. It's just easy only, right? And it's nice. Fine. So tomorrow when someone comes to show off this kind of a thing, you would know the answer and you will act smart, है ना? भाई हमारे बच्चे हैं. You should know all the things. Correct? मजा आया? Did you understand it? Fine. Tell me in the chats, by the way. I'll tell you one more thing. Two identical bullets are fired, one by a light rifle and another by a heavy rifle with the same force. Which rifle will hurt the shoulder more and why? Now this is a question which I would say it's easy. It's very common. It usually comes whenever conservation of momentum happens. This kind of collisions, है ना? These things happen. Now what is the question saying you? Two identical bullets. अच्छा, bullets are identical. मतलब mass of bullet is same. Fine, all right. One by a light rifle and another by a heavy rifle. One rifle is heavy. One rifle is like light. With the same force. Which rifle will hurt the shoulder more and why? What is the measure of hurting? The rifle which will strike you more will hurt you more, right? Now understand this, right? Understand this. क्या हो रहा है? Rifle ने bullet को push किया. Rifle pushed the bullet pushed the rifle. Whatever happened between these two. I don't care. There is no external force. Externally, you did not push the rifle, and it's not like rifle pushed the bullet afterwards. Whatever happened, rifle pushed the bullet pushed the rifle. Whatever happened between these two, I don't care. भाई अपना निपटा लो तुम, है ना? मुझे नहीं पता. मुझे बीच में पढ़ना ही नहीं है. Internal forces तुम्हारी, I don't care, है ना? That's why. this is an internal force. If there is no external force, this is an isolated system, momentum will be conserved, right? Momentum will be conserved, correct, right? No net external force means momentum is going to be conserved. अच्छा एक चीज बताओ, initially when both of them were inside, है ना, bullet was inside the rifle, and can we see both of them are at rest? Yes sir. Initial velocity of bullet is also 0. Initial velocity of gun is also 0. So can I say total initial momentum is 0? है ना? Mass of bullet, small m is for bullet, है ना? Mass of bullet into 0 velocity plus mass of gun into 0 velocity will be equal to what? When it struck the bullet. Bullet went this side, gun will recoil in this side. बिल्कुल सही sir. Why sir? If I take this as plus and this as minus, है ना? If I take this as plus, this as minus. So can I say, let's say velocity of bullet is VB, है ना? So mass into VB. Positive or negative? Sir, VB is in this direction. Which direction? This direction. It is a negative direction. Means this will be negative. Okay. Plus mass of gun multiplied by VA. Let's say the final velocity of gun is VA after collision. है ना? VA. Okay. Sir, VA is in which direction? VA is in this direction, right? This is VA. It will be plus. So M into VA. So अब ये total तो 0 हो गया. This is 0. है ना? So can we say, I'll just take it that side. M into VB is equal to M into VA. Can we say this? Notice. Can we say this? Right? We can say this. No. So, M into VB equals M into VA. This is what you got. So, I can say, same thing. MV equals MU. So, what is U and what is V? So if we are telling, you see, U and V is nothing. U is the final velocity of bullet, V is the final velocity of gun. That is fine. Okay. Now, M into VA and M into VB. Okay. See, this is one thing which was told you. What was the thing? K, force applied is same, right? Force applied is same. Mass of gun is different because rifles are heavy and light, but bullet is same forces applied means change in momentum for the bullet will be same, correct? So mv becomes constant, right? I would say mvb becomes constant, vb the bullet's velocity. By force same lagega, right? If bullet is same and force applied is same, so iska momentum change to same hi hoga na. So that's why m into vb is same. Can I say this is a constant? Right? Yes, sir, we can say it's a constant. So if mass into final velocity of the rifle is equal to a constant, can I say that velocity, the final velocity is inversely proportional to mass? Can I say that? Yes, sir, you can say that. Iska matlab pata hai kya hai? In very simple terms, if I explain it to you, you can understand it like this. Heavier rifle will have a lesser recoil velocity. Lighter rifle will have a more recoil velocity. Matlab, lighter rifle will go like thuk. Heavier rifle will go like thuk. Hai na? Getting it? So that's why I'm saying this can be derived, and this is what is written over here, right? So how can we say that? The bullet fire with lighter rifle will hurt more because recoil velocity will be more. So got this? We know why are we doing this? Why are we learning all of this thing? Because this is the target for the mission midterms, 100%. And you know what? This is not just a number. सर कुछ भी रखना था 100 बोल दिया मजे मजे में, ऐसा नहीं है. We are keeping 100 so that you work hard, keeping 100% in mind, because even if you miss, you will reach 95, 96, 97, 98, 94. कुछ अच्छा ही होगा. If you think 100, work hard like it is 100%, right? So that's why this is a mission midterm, and not just for CBSE students, for ICSE also, right? And other boards, whoever needs conservation of momentum. And very important topic, I'm telling you, today if it is sorted, no, class 11th में mechanics लगेगा ऐसे. सर क्या ही है पूरा मैकेनिक्स तक यू विल फील लाइक आई एम कॉन्फिडेंट. नहीं तो पता है बच्चे इतने परेशान हो जाते हैं मैकेनिक्स में. आई एम टेलिंग यू, पीपल गेट सो स्कैर्ड ऑफ मैकेनिक्स दे फील लाइक सर कुछ समझ नहीं आ रहा. डोंट डू दैट. अंडरस्टैंड इट. Watch it again if you feel some problem is there, because I have covered everything nicely. You might have missed one or two words. You might not be able to hear it. कुछ हुआ होगा, focus lose हुआ होगा, but if you want, you watch this session again. In this mission midterm, we are giving you chapter revision notes, the mock test questions. We are also giving you one-shot marathons, exam-focused questions, doubt-solving sessions, and strategy sessions, right? So everything we are giving you. How will you know all of this? If you are a subscriber to the channel. Make sure you subscribe to the channel, because notes I'm giving you on Telegram. There are two action items for you. subscribe to the channel. Make sure you subscribe. Make sure you subscribe. You make your class friends or classmates subscribe, because देखो अच्छी चीजें हैं. It's good to share. Sharing is caring. We call it, no? So share it with your friends so that tomorrow you as a group of friends will become like, aha, ये batch बड़ा अच्छा है. इस class के बच्चे बड़े अच्छे हैं. It's okay, है ना? Study together, solve your doubts together, ask your questions to me together. That's fine. But make sure you call other people also, right? Subscribe and make others also subscribe. Join Telegram, very own family. Target is 100K, by the way, right? जल्दी से पूरा करना है 100K subscribers. And on Telegram, I am giving you notes, poll questions, homework questions, all these what we give you on Telegram. So make sure you are a part of Telegram as well. In the description, there is a link of Telegram group. Make sure you join it, ठीक है? जरूरी है. And on every Friday, we come 3 p.m. live. I think last time or sometimes we might miss, but we'll let you know. But if we are coming live, we'll come with a bang. मजा आएगा. मैंने किया हुआ है दोबारा, अच्छा लगता है. Right? So people, make sure you are a part of the Telegram group. And this is one homework question. I would say just take screenshot very quickly. I want this answer in the comment section. See, I'm not there in this video today, but I'm expecting that you have understood everything and you will be able to answer this thing. Do falling objects conserve momentum? Explain. It's a good question. It's a good question. Take a screenshot. Try to answer in the comment section. And I'm looking for answers, by the way. है ना? खाली नहीं छोड़ना उसको. People understand this. We have got you covered from every nook and corner. हर तरफ से we have got you covered. Don't worry about this. But what I want from you is, I want you to put a thumbs up. Put the like for this video if you think this was helpful. If you are a CBSE student, if you're an ICSE student, if you're any other boards who liked conservation of momentum, who was looking for a good video on this, make sure you press like if you liked the video. ज़बरदस्ती नहीं है. अच्छा लगा तो like करो बस, ठीक है? You share it with friends. If you think this was helpful, share it with your friends. ऐसे लालच नहीं करना. Don't be greedy. बस मैं पढ़ूंगा और किसी को नहीं पढ़ाऊंगा. ऐसा नहीं होता है. जितने लोगों को spread करोगे, the more you spread, the more other people will watch, the more you will have good people to discuss good content. ऐसा थोड़ी है टाइम पास करना सबके साथ जाके. Make sure you share it with friends who you feel deserve this. ठीक है? Subscribe to the channel because that's important. And if you are still not very much motivated for subscription, let me tell you something else. Every week, the first 1,000 subscribers are getting a gift. Sir, what is the gift? The gift is in the description. No, say description बहुत जरूरी होता है. We have a lot of important links in the description. In the description, there is one more link of the shop.byju's.com. There, if you click, no, it's a MLP, the mini learning program pack of 3 sessions, which was 399 rupees before. But if you are the first 1,000 subscribers, you can use this code. The moment you click, it will ask you for your details, something, and there's a coupon code. Use YT first, and that 399 will become 0. For free, you can trial this. The 3 pack sessions of mini learning program. इसमें क्या है? 2 teacher model. I'm telling you. Most of the students have already tried. बहुत सारे लोगों ने try कर लिया already, right? They liked it. If you are the one who do not know about this thing, make sure you do because free है. हमेशा के लिए नहीं है. पहले हुआ करता था, बीच में छट गया था, अभी दोबारा आया है only for the first 1,000 subscribers, right? Make sure you try it. Free कमाल है, बढ़िया है. Try करके देखो. पसंद आया अच्छा, नहीं पसंद आया कोई बात नहीं, है ना? So that's why this is something I'm telling you. Make sure you subscribe and make sure you try this. Till then, take care, keep learning, and I'll see you again. Bye-bye.